This pen is like not working. Huh? I'm going to turn it over because it was standing out the other way, so I'm going to turn it over and see if it does it, and if not, then tomorrow I'll chuck it. Just try to write over it with this other one. That doesn't sound good. All right, transformations, functions, that map, real numbers, two real numbers, well, your calculator can transform it, but you're going to have to tell me what's happening with it. Bat. All right, rigid transformations. Leaves size and shape of graph unchanged, including horizontal translations. Vertical translations. Reflections, or any combination of these. We have non-rigid transformations. So these distort the shape of the graph. Includes horizontal and vertical stretches and strengths. Okay, sometimes I'll call these like basically the compressed ones. Okay, if it's compressed or stretched. A vertical translation is a shift of the graph up or down. A horizontal translation shift of the graph left or right. So starting to look at what these actually look like, okay, for translations, we are going to let C be a positive number, or sorry, let C be a positive real number. We're back to C being a number. Following transformations result in translations of the graph of y is equal to f of x Okay, so we can have horizontal or vertical, so starting with horizontal. Translations. You can have y is equal to f of x minus c, or y is equal to f of x plus c. So with these ones, the top one is a translation to the right, c units. Bottom one is translation to the left, c units. Okay, so remember with these ones, the shift goes the opposite direction of the sign. Then vertical translations. You have y is equal to f of x plus c, or y is equal to f of x minus c. So this top one is a translation up by c units, and then the bottom one is a translation down by c units. Okay, and this is true for any type of function. Okay, we're not just, like last year in Algebra 2, we just did like parabolic functions. Okay, so we just did them. I made you do them by hand. I made you be able to graph them and all of that. But now, basically, I'm going to be giving it to you. And without using your calculator, you should be able to tell where it's going. But I'll probably also give you your calculator, at least for some of them, and let you use it for the shifting to figure out what's going on. But some of them I probably will make you do by hand, just knowing these rules and stuff. Or a question on your quiz or test might be like to tell me the rules for like translating and stuff and how you know what direction things go. And then I might give you your calculator to actually do the problems or something like that. We'll see. So let me know when everybody's copying this stuff down about translation, and we'll move on to reflection. Yes. Yeah. I should put that on there. So for the vertical ones, the shift goes the same direction as the sign. That's a weird F. It's like... That's so unfortunate. Is everybody done with translation? Okay. I should do all of mine on the weekend. What? I thought you said my mom does it, and I was like, I mean... Alright, so that was translation. Okay, so now we're going to move into reflection. Okay, so reflections across the axes. Reflections across the x-axis. Have points x, y, and x negative y. Reflections across the y-axis. Have points x, y, and negative x, y. And then reflections of each other across a line. 2 points that are symmetric. With respect to each other. Or sorry, with respect to a line. I said the right thing, apparently just wrote the wrong thing. Well, what do you want instead? You just don't want anything? Maybe I'll bring in something on Friday. Thanks. I do have lunch duty. It's very unfortunate. Stuff this period. Maybe Ryan can be absent on Friday. Then I'll just come raid the party. Alright, so reflections. The following transformations result in reflections of the graph of y is equal to f of x. So across the x-axis, it would be y is equal to negative f of x across the y-axis. Y is equal to f of negative x and through the origin, y is equal to negative f of negative x. There's 3, and then there's just one more little sentence I'm going to write. How small is the sentence? Like a line and a half. You could probably wedge it on a line though. You usually have the extra little like half line at the bottom. I'm sure you could use that too. Well, the graph of an even line or of an even function remains unchanged when it is reflected across the y-axis. That's amazing. I just remember, like, somebody running upstairs and being like, busted their head open, gushing blood, and I was like, what? I don't think so. I think it was a girl, because I was up here. Were you up here with me? Somebody was up here with me. Yeah, I think it was Isabel. She like came running upstairs, and I was like, what? I was like, are they okay? Is there somebody down there? I don't know. I was like, what the? Yeah. No, well, yeah, because you just told your mom, like, I won't get hurt tonight. I think wasn't Brandon there too? I really hope you can't hear that on my mic. Is that a baby? It's out of a king cake. They're out of a king cake. I have 1,000,000 of those at my house. It's out of a king cake, like a Mardi Gras king cake. They all have a baby in them. If you get the baby out of the cake, you have to buy the next one. Alright, stretches and shrinks. Let C be a positive real number. Then the following transformation result in stretches or shrinks of the graph of y is equal to f of x. So horizontal stretches or shrinks So you have something like y is equal to f of x over c. So it's a stretch by a factor of c. You literally just like put your pencil down and just like whoop. Yeah, put it down. You can't really see if I do it though. Hold on. I got it. You literally just, doesn't even have to be perfect. It can, if I do it fast, it works better. The harder one, the other side is, I think, harder. I think the other side's harder. Left side's easier. Alright, so if C is greater than 1, it's a stretch, a shrink by a factor of C if C is less than 1. Vertical stretches or shrinks. So y is equal to c times f of x. So it's a stretch by a factor of c if C is greater than 1. And I will say this is really talking about the absolute value of C, okay? Like, negative 0.5, okay? Like, that's going to be a shrink, okay? But like negative 3, that's less than 1, but it's still a stretch because the absolute value of C is technically what we're looking at. So I really should put absolute value bars on all of these. Sorry. And it's a shrink by a factor of C if the absolute value of C is less than 1. I'm not, or you're not? No. Whoop! It definitely helps to draw it if you do the sound. One of my professors in college could literally like draw those without looking at the board, and I was like, no. Yeah, the thing where they like do it behind their back. Like her professor could, like, they could just draw a perfect circle behind their back. Do you want to try? Because literally, I think it's hard. This is going to literally look crazy. Because you have to, like, not even look. See, I can't even, like, put the thing. You have to, like, it's really hard. So, I mean, when we're done, y'all can try it if you're just so ambitious. But I'm better at drawing a circle by actually looking at it. But even the ones on my computer typically come out to be kind of oval. I didn't do circles for that, did I? Oh, yeah. Yes, those. They looked round on the computer. Did you just say your whoops are in the wrong spot? Just mic everybody up and just you can hear everybody. Some days I don't know if that would be a good idea though. Who would be Dwight? I finished The Office like over the summer. I'd never like I watched all the seasons. Finally. Season like 1 and 2 is pretty boring. Once I hit season 3, I was like, I can get down with this. And I actually like the last couple seasons that most people don't like, so. I mean, I would watch it while I was doing other stuff. Like, I wouldn't usually just sit down and straight just, like, watch it. Nice. That's great. Are we good on this stuff? Do we have it all down? Yeah, okay, cool. Alright. So we are going to start out looking at some problems, okay, just some basic problems. And we'll do more with it tomorrow. I'll probably give you a couple to work on the last couple minutes of class just to start to get a feel for it a little bit better. But let's see. Also, just so you know, when we get to the ones, you'll probably remember this last year where I give you instructions like, okay, you have the function x squared. It's shifted right 3 places. It's stretched by a factor of 3, and it's reflected. Make sure you remember that order matters, okay, when you do those problems. Huh? Yeah. Yeah, so you would have to go in and add them and know what it's talking about. So, alright, let's start with some easy ones. Number 2, y is equal to x squared plus 5.2. So what's happening with this one? No. Up 5.2. Okay, it's not in parentheses. If this was in parentheses, it would be left 5.2 because it's outside of a parentheses. Okay, it's not technically attached to that directly. It is up 5.2 units. Alright, 4, y is equal to x minus 3 squared. So what's happening with this one? Right, 3 units. Okay, so inside the parentheses, we go opposite the direction of the sign. So this is going to be right 3 units. Basically, if you took the graph of x squared, okay, so it just, obviously it's at the, it starts at the origin. You literally would just shift it to the right 3 places. The whole graph just goes to the right. So your vertex, instead of being a 0, 0, is now at 3, 0. Yeah. So we'll look at some of these on our calculator too, some of the harder ones that have a lot of things going on. We'll look at them on our calculator, so as a way to kind of check and see what you're doing and stuff. 8, y is equal to x plus 50 squared minus 279. Yep, down 279 units. Okay, and you said left 50. Also, if you don't write units, I'm not going to take off, okay? We just technically don't know what the units are, so that's how we usually say that. But if you just were to say down 279, left 50, I'm not going to take off or anything. Sometimes I do that just because of ease. You know, there's are you trying to do the square? There's actually a button at the top on the Macs that is a superscript button. It'll actually be an X with a 2 raised in the top, I think. Oh, yeah, I would just do the little arrow thingy, or copy and paste it once you type it once. Copy and paste it over. Because if you use the little caret button, it'll type it for you too. It's above the 6. I was trying to remember where it was. Alright, so those ones were all for the graph of y is equal to x squared. Okay, we're going to look at the y, like y is equal to the square root of x. So y is equal to the square root of x minus 5. What do you mean? Hold on a second. I need to verify one thing really quick. Because I think if it's under the square root, I think we consider it as like in the parentheses like we did with 4, so I need to verify really quick that that is the case. Okay, yeah, so with the square root ones, okay, if it's inside the square root, consider it as inside the parentheses. Okay, yeah, so it's going to the right 5 units. Okay, so if we were to modify this one to be like y is equal to the square root of x minus 5 plus 30, okay, then we would have it being right 5 units and up 30 units. Okay, so outside the square root, it's still going up and down. If it's inside the square root, it's your right and left shift. Alright, so I'm going to give you guys like 3 to do for the last like 5 minutes. Okay, just to get a little practice on your own. Okay, and as far as reflected, if it's a negative sign in front of the X, you can just tell me that it's reflected. You don't have to tell me which kind of like a horizontal or vertical reflection. You can literally just say reflected if there's a negative in front of the X. Well, yeah, so I mean it would still be, you have to obviously still have to talk about the shift in that case, but then you would also say it's reflected because of the negative in front of the X. Graphical transformations. Alright, 1, 7, and 9.